Hello, how are y'all doing today? My name is Bernie Thompson and I'm president of Automotive Test Solutions. Today we have a very interesting problem for you. We have a 2000 Volvo S70. This came into a shop and they diagnosed it, and the DTC was for the throttle module. They put a brand new throttle module on it from Volvo. So this is a factory module that was put onto this car. The car was released and it came back and it has the same problem occurring. It takes between 20 minutes and 3 hours for this problem to occur. It probably has to do with heat, because as it's driven and it gets hotter, we start to have a failure. We have the same code back, which is a CAN communication error for the throttle module. In order to find out what's wrong with this car, we're going to need to take the ATS EScope, the A-trace, and we're going to connect it to this throttle module so we can figure out what's wrong with it. So let's go ahead and hook it up. We've connected the ATS EScope Pro with 8 traces. Now this throttle module has 6 wires, and you've got to be really worried about the powers and grounds. If you lose the power or ground, you don't supply enough current to the throttle module for it to work. So we're concerned about this because we've already put a brand new part on this car. Now that we're watching all the connections of this, we want to really focus on the CAN bus wires. And the CAN system looks really good right now. But this car is intermittent, so we're going to let it run until we can watch this car fail. We can see that the CAN signals are broken down. In order to figure out which end of the problem this is, whether this is the throttle body or the engine control module, we know it's not a power or ground because we saw it fail and the powers and grounds stayed good. I need to unplug the throttle body from this unit. And if I unplug the throttle body, then I'll be able to see what's going on. We can see that the signal was pulled up. The scope is in a strip chart rule mode. When you do CAN bus problems, you never want to be in a triggered mode. You always want to allow it to just go ahead and run continuously so you don't miss any data. In triggers, you miss a lot of data. The secret to doing a CAN bus is to watch it like this. What we want to do now is we're going to try to unplug this thing, and it's pretty warm. Okay, I've got it unplugged, and we're on the harness side of the motor. So now we're going to go ahead and plug it back in. We're plugged back into the throttle body, and we can see it failing. If I unplug it, it's good. That's the signal that's coming from the engine control module to the throttle body. We're going to plug it back in, and we're going to see that it failed. Okay, what the problem is the throttle body, even though this is a brand new manufactured part, it's no good. We need to replace this throttle body and reprogram it, and this car will be ready for delivery. Now that we've captured this data during this car's failure, we can look at that data and we can determine what's wrong with this CAN bus. Let's take a look at this. Right here we can see our 2.5 volt, and then we have our high coming into a recessive bit and the low going into a recessive bit. That means that we change the voltage. And we can see that we're good here. As we go back across into the save though, we're going to see where the CAN transceiver pulls the voltage up high, and notice how it pulled both lines up. This is the CAN transceiver that's in the throttle body has failed. When you do CAN problems, you don't want to have your scope in a triggered mode. You want to make sure that you're streaming all of the data, and you want to watch that data fail just like we did here. To look at a CAN and look at the frame values and look at bitwise arbitration is pretty useless. Unless you're the manufacturer and the engineer that programmed it, you can't discern what those bits indicate. But what you can do as a technician is to look at the overall bus and make sure that each packet of CAN information is formed properly. And we can see that when this bus failed, the packets fail. We no longer are forming them correctly. This is the CAN transceiver in the brand new factory throttle body. Now, in order to troubleshoot these type of problems, you need a scope that's capable of doing this. You need to be able to stream all of the data and record it, as we've just done. The ATS 8-Trace Pro Scope is the way to go if you want to fix cars fast.